Hey, everybody. Hope everybody's doing okay today. This is one of the parts of our Keep Writing series that we've been doing while we're all under this crazy pandemic. We've been interviewing a number of other companies. Ventum has been on here. We've had Training Peaks, Ryan Cooper was on, a number of other people. And today we're going to be talking about wheels, a whole bunch of things you know about wheels. And this is my lovely wife/quarantine partner. We've been doing this interview style. And so she's going to be asking me some questions. And I'm going to be answering. I've got a bunch of props and things, keeping myself busy making these things in here. So it's been fun. We also have come here, buddy. Our quarantine buddy sitting right here. He's ready for this too. So we're not quite sure what's going to happen, but we'll get started here. All right. First question, Miss Interviewee.
All right. So can you explain wheel width in depth?
I sure can. Common question we get is, wheel width, wheel depth, internal rim width, a number of different things. And so one of the props I have, this is a cross section of a rim. So this here is a full wheel. I basically cut a section out so we can talk about it. So this here is the cross section. So if anybody ever refers to wheel depth, it is the measurement from here down to here. So if you take a set of calipers, like I have here, and if you were to measure the rim depth on this, this one is 58.6 millimeters deep. And you can see that measurement there. So that's wheel depth. Anyone ever refers to depth. Wheel width can be discussed in three different ways. The first is the max width of the rim. So that would be the widest section on the rim at any given point. This one is 33.7. And then another common measurement you will see is brake track width. So brake track width is right here where your brakes would hit if you had rim brakes, and we'll talk about that in a minute. So that's this measurement here, which on this one is 33 millimeters. And then another common thing you talk about is internal rim width. So internal rim width, you look at the camera, is the distance between this point and this point. So if I were to take the calipers and I were to put them in the opposite direction, and I were to widen this out, you can see that this one has an internal rim width of about 25 millimeters. So those are the different dimensions.
Why
Depth,
do you need to know those?
Width, maximum rim brake, and then internal rim width. That's important to know because, number one, you want to make sure you're getting a wheel that's as deep, is suitable for your riding type and your styles. We'll get into that a little bit later. And then another reason you want to know, especially external rim width, is it going to fit your bike? We don't want anything that's too wide from a brake track perspective. All wheels that we make with brake tracks typically fit most bikes unless they're very old. And then internal rim width is important now because we know that a wider internal rim width makes you faster. And we'll talk about that more as well. And some upcoming questions, I believe.
All right, next question. What is the difference between tubed and tubeless wheels?
Very good question. First thing I think we want to clarify is there are two different types of tires historically before tubeless really came out, and those were Clincher, and then there were tubular. So a Clincher tire, this is a tire that I've cut a section of, and so a Clincher tire, if you were to look at the cross section, has these two sections here, which are called the Clincher beads, and those beads go inside here. So if I were to install the tire, if I think about installing that, my Clincher beads go on the wheel, and then when it is inflated, those beads sit in the area called the Clincher hook area. So that is a Clincher tire. A tubular tire is basically a tire that has no opening. It's a full round section. We don't make tubular wheels. We never have. But think of it like a solid tube, and then what you would do is you would take it and you would glue it on the inside surface. Changing them is very difficult. They're expensive. They're difficult to work with. They used to be used because they had lower rolling resistance, but today good old Clincher tires and tubeless are pretty standard. So the difference between a tubed and a tubeless wheel is on all wheels you're going to put a rim strip on. So a rim strip is basically going to cover these spoke holes. That's where the spokes come through. We'll talk about that in a minute, so that you don't get any punctures. But with a tubeless setup, you take your rim and you put just the tire on like this. And once that tire is installed, you have created a seal that, because your rim bed is now sealed with the tape, and you have a section here, and you have a special valve that comes out, and you put a bunch of sealant. Sealant is like a goop that goes in there, and it will prevent any air leaks anywhere. It kind of seals things up. Even if you get a puncture, it'll reseal it. One of the major benefits of tubeless. So when you inflate it with air, this whole cavity in here just fills up with air. So that's a tubeless install. Becoming more and more popular. My belief is that we're probably going to see the majority of road bikes will now be tubeless in the future. Mountain has been dominated that way for a very long time. A tubed wheel, and this is something that I kind of made in the garage, which I'm kind of fun to do, is the same setup. So if you can imagine, you have a tubeless here. So you have the Clincher tire and the rim, but on the inside of that you have an inner tube. And I think everybody kind of knows what an inner tube is. You fill it with air, and instead of it being sealed with sealant, this inner tube here goes inside and is inflated and gives you basically an inflated tire. You can see when it's inflated, it pushes those two Clincher beads that we talked about earlier into that Clincher hook area, and so it secures it on the rim. So that's kind of a cross section of what a tube looks like when it's inflated and how it holds the tire in place. So that's the main difference between tube and tubeless.
All right. So I'm looking at this,
Mm-hmm.
and I see these things that help the tire in place.
Yes.
What is that?
Good question. So I can take this off now. No, I don't need this anymore. Actually, I would. I'll use another one. This is an old rim profile that we used to have.
Do we want to answer a quick question on here?
We sure can.
Do the new wheels come with tubeless valve?
We do not ship the new wheels with tubeless valves. They come with tubeless rim tape, but you can get a tubeless valve if you want. We love Stan's products. They've been awesome for a very long time. They make extenders. You're going to need to get the right depth, but we do ship them with tubeless rim tape. We never used to, but all the new stuff ships with tubeless rim tape. That answers that question. So this was an old profile of one of our FLO 30 rims, which we used to make, which was an aluminum profile. And you can see here at this hook section, this section is just flat, and then it goes into a recess in the rim bed. Well, new technology and new advancements that we've made have what is called here either it's called a bead hump, or it's sometimes called other different things. What this helps with is when you install the tire, when you're installing that tire, and you put it on, when you inflate it and those beads go up and into that hook area, it helps lock them in place. It helps secure them. So you're creating a better tubeless seal. And I don't know if you can see it. It's a little bit hard to see on the camera. But the other thing that it does is if you are using a tube, because you can still use tubes with these wheels. They're made definitely for both. When that is locked in place, this bead hump also creates a much smoother transition from the rim bed back up to the tire profile. Traditionally, when you would install that, you look at it here, you push it in on this side, you have kind of a jump around there. That can cause some issues with your tubes. It can cause some other problems and things like that. So we've made it so that it helps prevent pinch flats and a number of other things once it's locked in place. So that's a good thing.
All right. So I believe this is gravel wheel.
There's a gravel wheel.
And I see no brake track.
It does not have a brake track.
All right. So how do I know if I need a disc brake or rim brake?
Very good question. So there are two types of braking systems in cycling wheels. One, the most common, well, used to be the most common, is slowly becoming the least common, is something that's called a rim brake wheel. It uses standard brake pads that most people have seen at some point. And these brake pads would go on what's considered a caliper brake up at the rim, and these close and stop your wheel. So right here, we have a traditional rim brake wheel. This is one of the new FLO 64s. And you can see that there is a different carbon surface right here. And that carbon surface is the brake track area. So when you brake, these brake pads close on this surface and it stops the wheel from spinning. A disc brake wheel would be a wheel like this, also the new FLO 64. But this does not have a different section where the brake track would be. It's a different construction, actually, so we make them differently. So you cannot brake on this surface. It's not made to brake. Where you do brake is you brake down here. This is called a rotor, and you have a caliper. Now, your bike will either have rotors like this, and you have a disc brake bike, or it won't. And if it doesn't, you have a rim brake bike, and you'll use traditional brake pads. We ship all of our FLO wheels with brake pads that work specifically with the carbon. So on an original, aluminum type rim, rubber and metal, they work. They stop really well. Carbon fiber is different. There's a number of different components. One is the carbon fiber that you use. The second is the epoxy resin. The resin is kind of like a glue that goes in, and you cook it and it heats it up, it hardens. And so there are a number of properties, it's called TG points, and a number of different things where if there's too much heat, you can create some trouble. So we specifically formulate brake pads that work very well with our epoxy resin systems. And not only do we not worry about heat, our epoxies don't really have heat issues, but the other thing you want to make sure is that the carbon surface and the epoxy resin, that you're actually getting a good bite. So that's why we ship all FLO wheels that are rim brakes with our own brake pads.
I have a couple questions.
Shoot.
If you are deciding between a rim brake and a disc brake bike, which would you go with? And what does the data show?
That's a good question. I own a disc brake bike, but in a wind tunnel, when you put one of these things on, it adds about 2 watts per wheel. Rim brakes are faster, and it doesn't change the fact, though, that I think everything's going to be moving to disc brake. I think we can probably make some improvements. One of the things that's beneficial about rim brakes is it gives us a lot more ability to be wider and do different things up around the tire area.
Disc brake.
Did I say rim?
Mm-hmm.
I meant to say disc. Thank you. Disc brake allows you to do a lot more stuff there. Have we seen a specific advantage? Not really. Right now is currently somewhat of a penalty when you're using a disc brake bike. However, I probably still would buy a disc brake bike unless I was really, really focusing on a very specific event and I was only concerned about like a TT and it was a 40K, something where I was trying to optimize everything. I'd probably go with a rim brake at that point.
Can you change a rim brake wheel to a disc brake wheel?
Rim brake to disc brake depends. So here's the thing: if you have a rim that has a brake track, that means that I can put brake pads on it. So if I had let's say I had a disc brake wheel, and for some reason had a brake track on it, I could convert it to a rim brake wheel. However, if I have a disc brake rim and I want to convert that to a rim brake, I can't, because this rim is not designed to accept brake pads. So that's something that I can't do. If you're okay with transferring from a traditional rim brake rim over to disc brake, you have to be concerned with a couple things. Number one, you want to make sure that you're going to get enough spokes up front to be able to provide you with enough stability in the wheel to stop. So our front wheels traditionally, and I'll show you the two here. Luckily I picked the right ones. What?
Okay.
This is a front wheel with rim brakes. And so when the wheel is spinning, it spins around the center hub. And when you stop, you grab it here. So there's really no force or anything that transfers through the spokes. I grab it here and it stops. So we can lace a front wheel, which is called a radial lacing. So the spokes just come straight out. You're not driving from here. So there's really no torque at the hub that would flex these spokes. So traditional rim brake front wheels have few spokes up front. On a disc brake wheel, what happens is when this wheel is spinning and you try to stop it here, the top of the wheel, the rim section, wants to keep moving. And so what happens is you torque the hub and your spokes want to go in the opposite direction. You want to flex them. That's why you see pretty much all disc brake wheels, you're going to have probably a 24 two-cross lacing, which means the spokes cross each other once and twice. And that gives you a much sturdier build, especially for something like braking with a disc brake. And that's why you see even on a rear wheel, they're always typically crossed because that's where you drive from. And your cassette, as you torque that, will also move the spokes.
Let's see, there's a question right
Couple
here.
questions?
Is there a way to convert through axle to quick release with a road bike?
Through axle to quick release, you can if you have the right end caps for the hub. So this one here is the rim brake. Has what's a quick release end cap, so 9 mil. This here wheel is a disc brake wheel. Pretty loud, wasn't it? Has a 15 mil through axle. This is for 15 mil. It's the bike that I have. A lot of times they come in 12. And this end cap for us pulls off. So if you have your hub has the option to basically swap that out. You would just put a quick release end cap on there and push it in place. So if your hub manufacturer allows for that, yes, no problem.
Disc brakes, the new disc brake for FLO wheels, when are they available?
All of the new AS series, which is our all sport series, basically you can take it anywhere you want except for crazy mountain bike stuff and half pipes. That is shipping now, so we're hoping to have that in probably early June for shipping.
All right. So now, what makes a good wheel? How do you know that you're getting a good wheel? Is the wheel that came out right good enough?
Delivery man.
Sorry.
So a wheel is only as strong as its weakest link, so it's just like a chain. And so there are 4 basic components that are part of a cycling wheel. Oh, good, thank you. There is the rim, there are the spokes and nipples, and then there's the hub. So let's first talk about the rims and what makes a quality rim. So the first thing you want to consider when looking at a rim is there are kind of 2 types. So I'm going to take this tire and tube off. Our original wheels were made from something that's called an aluminum carbon wheel. So it's got an aluminum rim and then it had a carbon fiber fairing. So if you were to look at the cross section of this, you can see that there are 3 parts. There's the first wall and second wall of the rim. Then there's this chunk of carbon that goes around that is non-structural. Now, what does that mean? What that means is that the spokes actually do not connect to this carbon fiber. They connect in here at the rim. And so the spoke passes through the carbon and comes up and connects here. So the reason the carbon is there is basically to create an aerodynamic profile. But the carbon itself is non-structural, so there's no load on that carbon fiber. That's one type of rim. This is a carbon Clincher rim. And as you can see, if you compare it to this one, this here is the first wall. This here is the first wall. This is the second wall. And on this rim, the second wall is down here. So the spokes connect right here, and the nipples are down in this area. And so what that means is that this section of carbon fiber here is structural. So that goes and it holds a structure and holds the structure in place. So it's part of that structure. If you are going to look for a quality rim, one thing you want to make sure of is that you're getting them from a reputable manufacturer. Aluminum, if you're making an aluminum rim like this, as long as the internal structure is fine, it's really kind of difficult at this point to make a rim that isn't necessarily going to be safe. It may get some cracks or some certain things like that, but that's kind of unexpected. With a carbon fiber rim, especially if you're braking on it, you get a lot more potential trouble. So the biggest thing that can happen, and this happened a lot when carbon rims were first made back in probably late 90s, early 2000s, and even today you can still get rims that will do this if you get them from a manufacturer that's not using really good techniques. So I think there's a couple other things we can talk about here as well. Is this here is a rim that is from a factory that we just tested. So this doesn't come from our factory. And one thing that I think is important to show is one thing we haven't talked about, and I think it's careful to talk about, is we get questions about hooked and hookless a lot. So what is a hook? So a hook is, let me grab something to point with. One sec. Okay. So if you look here at this section, you can see that this goes up and there's a piece that comes out. That piece that comes out right here is called the hook. On a rim that is a hookless rim, that doesn't exist. So the reason a hook is there, traditionally, is to help hold this bead in place. So if you have a tire that's installed, if you're taking a corner, if you put a lot of air pressure in, that bead is going to help hold that down. Now, there's been a lot of debate recently about hooked versus hookless. What is good? Why do you need one or why do you not need one? We have tested hookless rims like this one. Like I say, we don't make them. And the reason we don't make them is because you can become very limited to the number of tires that you can use. So, for example, the Continental GP 5000s, when we were testing, the 25 worked on hookless. We had blow-offs with 28s and 32s. And that's at a pressure that's not a pressure that would be something that you would think wouldn't be okay. We have never seen a blow-off unless we're at extreme pressures where we're actually testing rim stability. Typically the rim cracks before you're going to get anything that blows off over the edge. So for us, from a safety perspective, first and foremost, we do not make anything that's hookless, just because you have that potential of it blowing off and because you're severely limited to the number of tires that you can use. Hooked or hookless rims in mountain bike with lower pressures can work very, very well. For road, though, it's something that we've always stayed away from. So you may ask the question, why do people use hookless? And the first reason they do it, from our understanding, is to make a rim like this is cheaper. So you do not have to. It's a different structure. You don't have to add the fiber in. It's less man hours. It's a cheaper rim. Something else that's also kind of interesting to look at, and this rim comes from a factory that is probably, could be technically questionable to some extent. And if you look, when you cut a rim like this is our rim, what you want to see is all carbon fiber, which everything in here is black, it's carbon fiber. On this rim, you start to see pieces that are fillers. So these different components could be fiberglass, it could be a number of different things. I've seen some frames that have been opened and there's a bunch of paper in there to try and fill voids. So first thing you want to do when you're buying any rim is you want to make sure that you're getting it from a good manufacturer. If we've shipped a lot of rims. We've worked with one factory our entire life cycle, and so we make sure that those are good quality rims. So that's the first thing you want to make sure you're taking care of, and that's what helps with a good quality rim.
Hook bead or channel?
What's the question?
Hook bead or channel?
Hook bead or channel. This is the bead. This is that's the tire bead. This is the clincher hook area, and this is called the rim bed. What we call a rim bed. I've heard people call this area the rim channel. There could be a number of different names for it, but that's how we would describe that. If you're calling it something different, like a bead channel, I suppose you could call it that. Works the same way, though, I suppose. But yeah, that's basically how it works. Another thing we want to talk about with rims too is molds. So it's always been this way, but if you were to go over to a rim factory, could be anywhere in the world, you can go into a rim factory and you can buy what's called an open mold rim. Open mold rims are something that the factory owns most of the time, and I've never seen one that has been designed. They make a random rim shape and they put them out. It could be based on depth, it could be based on width, it could be based on a number of different factors, but there's really nothing in that rim that has been designed to make it aero or fast or anything like that. So you can go over, you say, I want 100 of those, you put your sticker on it, you have a wheel company. Private molds, or molds that are owned, that are proprietary, typically are made by companies that put a lot of R&D, a lot of time and research into making a rim shape. For us, what we do is we do a lot of computer simulation. We do a lot of on-road testing to understand things like aerodynamics and rolling resistance. We'll talk more about that later. But once we develop a shape, we then go to a factory and say we want to open our own custom mold. We're the only ones that are able to produce from that mold. But what we're getting a shape of a rim that produces great aerodynamics, great rolling resistance numbers, and it provides not only a quality structure, so the factory is making really good stuff, all carbon fiber, good components, but it's a rim that's going to be fast and aerodynamic.
Before we get into the other components,
yes.
Do you want to talk about where manufacturing happens and does it matter where it's made?
It does. If you're having a wheel that is made in the United States, for the most part, wheels made in the United States are made by brands specifically, and most of those brands are not manufacturing for other companies. So, and most of the brands that I know that are manufacturing in the United States make great wheels. If you are not manufacturing yourself and you're looking to outsource, you have options. China is an option. We originally started with some stuff in China. We were about a month away from producing our first wheels way back in 2011. And we got a call from that factory basically saying that they were waiting for us to come over and teach them how to make wheels. So you're extremely hit or miss in a factory from China. That's nothing against the Chinese. There's some factories over there that are exceptionally good, but it is more difficult to find. This is a rim. This is the one that has I don't know what that stuff is. That comes from a factory in China. I would not personally use that at all. I don't think that's a good idea. All of our rims are made in Taiwan. Taiwan is sort of the mecca for carbon production. They are experts at what they do. We source factories. Back in the day, we went through a number of different ones. We picked one and we have never left. They make a phenomenal product. They're wizards with carbon fiber, great structures, and we go there. So if you're going to look for a rim, it's very common that people will say, hey, I found these rims on eBay and these wheels and they look deep and they look this and they come from this, it's direct source. I'll buy them from this factory, and just be very careful. Most factories that are manufacturing are going to sell to brands that are making. They don't have to sell products of their own because they're making enough money because they're good enough to supply products for others. They don't have to create their own brands. So just be careful of that. If you're going to buy something, even if it's not something from us, make sure you're buying from a reputable brand so that you're getting a product. Number one is safe and is a quality product.
All right, so
Next
other
component.
parts of the wheel. We've got what? Hubs,
Rims.
bearings,
Spokes. So spokes and nipples. Spokes and nipples seem very simple, pieces of metal that hold things together. However, they are not. A lot of times, the question?
I think a couple shipping questions. I don't. One is shipping to the UK easy and cost effective?
Shipping to the UK is easy. It's free. We pay for it. You will pay your standard import and duty tax rates, which, if I'm not mistaken, through my education of import and duty, is going to be your 20% tax and a 4% duty. So, pretty simple.
Are there any delays so far because of COVID on new wheels?
We do not have any confirmed delays at the moment. If anything changes, which it could, we will let everybody know as soon as possible.
And now we are talking about spokes.
Spokes.
And what color spokes are we going to be offering?
Black. All the new wheels are going to have black spokes.
Yes.
So I'm super excited about that. These are prototype wheels. These are production prototypes that we use for testing, wind tunnel, certain things like that. These have silver. All the new wheels are going to have black spokes only, and that makes me really happy. So spokes, let's talk about those. Spokes, you think it's a piece of metal. It's super simple. You connect them. It's not. Spokes are surprisingly very difficult to make. If you make them poorly, they break, they snap, they go to true. We use what we consider the best spoke in the world. It's something called a SAPM CX Ray. It has an oval arrow profile, double butted, which means that it's round up here and down here, which provides strength. The materials that SAPM uses is a special formula. They're very strong. They stay true. Most of the times you're going to break one of these, it's going to be a rear wheel, and it's because your chain jumps off, goes in, and comes in contact with them and cuts them. You're not typically going to break a spoke from standard wear with a SAPM CX Ray. It's possible, but it's very rare. Their life durability is incredible. And what that allows us to do is it allows us to limit the number of spokes, so it makes a more aero wheel. You're not overbuilding. So it's going to make a wheel that's livelier with the right amount of spokes and build. You want a wheel to move, but you want it to move the right way. You don't want it to be soft or too flexible, but you want it to respond to you the right way. And spokes are a big part of that.
And to my understanding, that that you're getting, CX Rays are the best spokes. But to look out for poor quality spokes, you typically could see more spokes on a wheel.
You could see more. Exactly.
Okay.
Shaking the words right out of my mouth. So if you see like a standard OE wheel, OE means original equipment. So a lot of times it comes just on a stock bike. And what you'll get is you make it 28 or 32 spokes. That's a super overbuilt wheel. And the reason they do that is because you're using a spoke that is of poor quality. And
it's not very aero.
Not very aero either, no, because you're putting too many spokes in there. But you know all this information. And so basically, when you do that, what happens is the wheel goes out of true because the spokes aren't made very well, and the spokes will break from just standard riding. And the reason they add so many additional spokes is they're trying to compensate for a cheaper spoke. A CX Ray retail is about $3.30. Cheap spokes. We've talked to vendors who have offered to sell us spokes for about 3 cents a piece. So $3.30 versus 3 cents. That's a kind of a red flag, and that's why they break. That's why people overbuild. Nipples. There's basically two types of nipples from a material perspective: brass and aluminum. Are aluminum lighter? Yes. Are they worth it? Not at all. Only nipples you should be using are brass nipples. Just don't even question it.
What is the purpose of the nipples?
Purpose of the nipples. Mm-hmm. So on the end of a spoke is threads, like a screw. On the end, the nipple is like a nut. So when you're building a wheel, a rim right out of the mold is pretty round, but it's not perfectly round. So if you spin it, you have like a tire, a rim gauge on it. You'll see oscillations this way, up and down, and you'll also see oscillations left and right. So the spokes And the nipples, through the top of the rim here, you use a spoke tool and you tighten them. And so there's certain tensions that you have, like on a front wheel where 90 kilograms force. We want to have that so that it holds the rim round, true, both laterally and radially. And it also provides enough stiffness. So when you pedal, the wheel's going to respond properly and all that sort of stuff. So the nipples are there to basically tighten these spokes into place. And then we go to hubs. Hubs are seemingly simple. The biggest thing you want to be concerned about with hubs are two things. Number one, the bearings that you put in there. So a hub has on the inside bearings. So there's an axle that goes through the middle, and on the inside of that axle is a bearing, and then on the outside of that bearing is connected to this hub shell. So that's what allows the wheel to spin. The bearings on the inside, if you're using a poor quality bearing, number one, it takes a lot more energy to roll that wheel. You can feel it when you spin them. It's kind of gritty. You feel some slight vibration in there. You can run into a number of different problems with bearings. There's a rating system for bearings called ABEC 1 through 9. 9 is super, super smooth. If you're using a super good quality bearing, that means that the surfaces of the races and the balls are extremely smooth. And so as it rolls, then your wear is it takes longer to wear. When you have a bunch of imperfections in the surfaces, it's like running your hand over something smooth or running your hand over a bunch of sandpaper. So there's more interaction there, and so your bearings, they can wear out quicker. Tolerances, so if your inner race tolerance and your outer race tolerance aren't right, you can have issues there. So you really want a good quality bearing. There are two types of bearings really. There's stainless steel or steel balls, and then there are ceramic bearings. We used to offer a ceramic option, and then we stopped offering that because what we found was that unless you're using a bearing from a company called Ceramic Speed, ceramic bearings don't really provide a ton of benefit over a really good quality steel bearing. So,
and you want to make sure that the seal, right? That's important.
The seal of the bearing?
Mm-hmm.
Yes.
Dirt and all that getting them.
Yeah. So we'll talk about those in
We're not there yet.
We'll get there. It's all good. Thanks for keeping me on my toes. So a bearing. If you're gonna go ceramic, Ceramic Speed, the guys over there, great stuff. They're expensive. So retail, you're probably looking at $800 or $900 for a set of bearings. So for us, we made a choice to go with a really good stainless bearing, steel bearing, just because it didn't, for us, really justify the option of kind of doubling the price of the wheels. But if you want ceramic, we highly recommend Ceramic Speed. There's a couple types of bearings. There's cone bearings, so you kind of have to preset tensions. So your end caps have certain tensions, and the way the bearings are built a little bit different. We don't use any of that. We have just, you put your end caps on. It's a sealed cartridge bearing, so you don't have to re-grease them. Basically, there's a seal on the outside, and when that bearing runs out, I mean, you're probably 10 to 20,000 miles before you would really want to consider it. Then you just take that whole bearing cartridge out and you put it back in. You're not re-greasing, you're not doing all that sort of stuff. So we made those choices just for ease of use and very good quality bearings. The other thing you want to be concerned with a hub is the actual manufacturing. So you have a hub shell, which is made of aluminum, 7075, aircraft grade, and then on the inside you're going to have an axle. So if those are made in a way where they're not straight, or the tolerance is bad, the machining is bad, your bearing can get false loads, meaning while it's supposed to be sitting on a flat surface, your bearing's supposed to come in and sit on this flat surface. It could be off. It could put a false pressure on there. You're going to wear your bearings, and you just get a bunch of stuff within the wheel that you don't. So you just want a really good manufactured hub. I don't really know of companies, good reputable companies that are making hubs. All our hubs are proprietary to us. They're all FLO Vortex hubs. They're one of the things that people talk about the most that they like. If we ever had issues with hubs, we would definitely take care of that. The other thing you want to be concerned with hubs are your free hubs. A free hub on a rim is this thing here. This is where your cassette goes. And when you stop pedaling, that's the magic of the free hub. It allows your wheel to keep spinning while your chain stays in place. So on a free hub, you have a seal here, and you just want to make sure that you have a good seal. If not, you get water in there, you get a bunch of dirt in there, and that can cause some premature wear. So that's basically it. That's kind of what makes a good wheel. If you have all of those components packed together, and you're getting quality rims, good spokes, good hubs, good nipples, and you get somebody who builds the wheel well, all our wheels are hand built, you're going to have a really good quality wheel. If you say, hey, I'm going to use a really good hub and a good rim, but I'm going to use cheap spokes, not going to work very well. Swap that out with a bad rim or a bad hub, same thing. So you want to make sure that you have the best quality of all the components you can get, a good build in your set.
All right. I'm wondering if we hit this topic and then that topic. What do you think?
That's a good idea.
Because I think this is what's more important, aerodynamics or weight? We all know aero.
That's the big debate. So I've always explained, well, first of all, the most important one by far, like a factor of probably 60 to 1. Tom Manholt, a great guy, very smart guy, has done some studies on that. And aerodynamics is about 60 times greater of importance than weight. We've done a lot of studies with a guy named Ryan Cooper, who's actually on this summit. So you'll hear from him, brilliant guy. We had about a 4.5 pound wheel set that we did some work with, and a theoretical kind of like 2 pound wheel set that we ran over all the different courses that we could come up with, even the most extreme courses. And in all situations, the aerodynamic wheels were faster. I think there was like the Alpe d'Huez. She was like maybe 3 seconds. But every Ironman course, Savage Man, which is the hilliest Ironman course, every road race that we could come up with, a very heavy aero set is always performs better than a light non-aero set. So why is there a myth with this? First and foremost, I think the biggest reason, this is just my belief, is that weight is extremely easy and cheap to measure. So she has a bike, I have a bike, we can get a scale and say my bike's lighter than your bike. And if I take more weight out, I'm going to be faster. And so there's a really easy way for me to do that. If I take, this is her wheel and this is my wheel, how do we know which one is faster aerodynamically? There's no cheap, easy $10 bathroom scale trick that you can use. And so my belief is that it's kind of, and it's difficult to understand. It's difficult to see how that works. And so I think because of that and the misunderstanding is that people have always thought that weight is more important, but it's not. A good aerodynamic performing wheel with additional weight will outperform a very light wheel. And so these wheels, the new ones, are not even close to 4.5 pounds. So we can't find a scenario where a theoretically meaning we can't even make a wheel that light, wheel would outperform it. So aerodynamics trumps in all cases.
Right. So that being said, what wheel depth is best for me?
Good question. So
that
do we, if you're
aero matters, but
it does. So let's talk about, good question.
Do you want to answer the question?
I will.
Just kidding.
So here's the thing. Why do I want a rim that's this deep or even deeper? What's the purpose of that? Typically, a wheel that is deeper is going to be more aerodynamic, meaning that it takes less energy to move you through the wind than a wheel that is shallower. So we compare all of our wheels to like a standard OE wheel, which would be what we use, the Mavic Open Pro. And we've shown that it's about, for a set of wheels, you're going to save about 10 watts, roughly. I mean, it's different for different wheels, but a good aerodynamic profile is going to save you a lot. The deeper you get, though, you have another factor that you have to consider. When you're riding into the wind, a lot of people think that the wind hits you straight in your face. It's not true. Most of the time, it's hitting you at some type of angle. So if you think of this as your wheel, the wind's going to come in maybe at an angle like this, not straight on. And that's considered a yaw angle. So that whatever that angle is called a yaw angle. So that means that when the wind's coming in, it's not only just hitting your tire, but it's also hitting this surface, which is the whole way around. So if you were to put your hand out the window when you're driving in a car like this, you can feel the air move you back. Your hand's like this, you feel like you can cut through it. So the deeper the surface, the more interaction you're going to get when the wind actually hits the side. So on a front wheel, you have the fork, and so there's a steering axis. So if you have a very, very deep wheel that is not optimized to balance that force, what happens is when you get a gust of wind, your front wheel wants to twist in the handlebars, and that's a problem. It's scary. I've had it with bad wheels, and it's terrible. All of our wheels are designed for two things aerodynamically. Number one, we want them to be very fast aerodynamically, which means they has a low. You don't need many watts to move through the air, but we also want to make sure that we're not creating a profile that's, hey, it's very fast, but anytime you're in wind, you're going to get a lot of twisting because that's horrible to ride. So we have a weighted algorithm that solves for that in software, and yeah, that's very, very important. So that's one reason why if you're going to pick a set of wheels, depth matters. Now, even though we do optimize for aerodynamics and yaw torque, or the stability of the wheel, the deeper you go, you're still going to feel it to some extent. So if you are somebody who is an athlete, you're racing, let's say you're a triathlete, or you're a road cyclist, or even you're a gravel cyclist. This is our gravel one. It's first aero gravel profile in the world, and it matters. It's still about 12 watts, even with 10 watts, even with a giant knobby tire on it. So we're super excited about that. But you want to make sure that you're going to pick something that's going to be fast. And for anybody that's racing that spends that amount of time on a bike, a rim that is 50, 60, even up to 70 millimeters deep, you're really not going to have much issue handling that in the wind because they've been designed that way. If you're a recreational rider, you may want to move down to a 49 mil profile, which is one of our wheels. You're not really worried about super, super top end speed. They're still very fast, very aerodynamic. And the difference you're going to see from let's say a 49 to a 64 or even our 77 mil depth is probably maybe 10 seconds to 20 seconds over like a 100-mile race. So if you're going to limit your stability, because of that matters. So one of the rules we always go with is we want you to be on the deepest wheel that you can handle. On paper, our 77 FLO 77 right now is the fastest wheel that we make, especially when you're considering a 28 mil tire. So that being said, though, if your body, if you're racing, is the biggest drag component that you have. So if you're fit on your bike really well and you're in the aero position, that is the fastest you can be. If you have to come out of that aero position for any reason, then you're losing a ton of time because you're not very aerodynamic. So if you are using a wheel that is deeper than you can handle, especially on the front, let's say you should be on like a 64 mil wheel and you say, hey, well, on paper the 77 is faster, so I'm going to use that one. But you're coming out of the bars for any reason, you're actually losing more time on the deeper wheel than you would be if you were on the shallower wheel and you just stayed in the bars. So that's something that you really need to consider. You want to be on the deepest wheel that you can handle. The rear wheel is a completely different story. There's no handlebar, there's no steering axis in there. So typically you can go with even a full disc wheel on the back. It's not going to bother you. It actually helps stabilize the bike too. It moves something called the center of pressure back. That's a topic for another day, but you don't have to be super worried about the rear wheel. The other thing you want to consider anytime you're picking a set of wheels is your mental component. So if you are somewhat sensitive to wind or anything like that, if you're worried, anxious, or thinking about your gear when you're racing, you're not focusing, your heart rate's going up, and that's not something that we want. So if you're somewhat worried on a 64 mil wheel and you feel like it's going to bother you the whole race and that's all you think of, we would recommend you size down as well because it's going to keep you calm and moving through the race, which is a good thing.
Can you clarify a little bit? Because a lot of times you hear you want to be on the deepest wheel that you can handle. Previously, the FLO 90 has been the fastest.
Correct.
However, the new line has the FLO 77. The new All Sport line has the FLO 77, and the FLO 90 carbon clincher has been discontinued.
Correct.
Why is that?
Very good question. 2 reasons. Number one, we have learned that a much wider internal wheel, internal rim width, is faster. That goes into rolling resistance, not really aerodynamics. And so what we did is, because we widened the inside, this here is this is the original FLO 45. It's a 17 millimeter internal rim width. This here is the new FLO 64. It's kind of hard to see, but that is a 21 millimeter internal rim width. You can almost fit this rim inside of this rim. It's a significant difference. So because we went so much wider, we had to redesign the outside aerodynamic profile. So we made something that was fast, around a fast internal rim width. In doing so, what we realized was that we didn't need the depth. A 77 mil wheel was actually faster than our original 90 millimeter wheel. And when looking at the algorithm, we decided to increase the stability, because we said that stability is important, and also increase the aerodynamic efficiency. We could do that with a shallower wheel. And wider is becoming faster for a number of reasons. And so we have discontinued the 90 millimeter wheel. It was, to my knowledge, the deepest wheel that was being made currently. Other brands have been in the 70 and 80 mil range. And because we widened it, we finally realized for us that we didn't have to compromise the speed of a deeper wheel, because before a shallower wheel didn't make sense for us, because you could get an additional boost. But now, because we've widened it, we have made that decision to move in that direction. It's a faster, more stable wheel.
Awesome. There was a question. Is this why the new models have different depths than the older versions? What led to that decision? I think that.
Yeah, so I mean, good question. We give, so the way we design wheels, traditionally wheels are designed where people would take a bunch of random shapes that they would make. It could be made out of plaster, it could be made out of a number of different things. Who knows what they were made out of? They would go to a wind tunnel and they'd take 12 and they'd say, well, which one's the fastest? That's really good if you're only testing one versus 12. Well, 12 is better than one because you have 12 options. With aerodynamics, there's not an equation to basically say that something, you can't just solve it and say, well, this is the fastest shape. You have to test. In a wind tunnel, that's really, really difficult for a few reasons. Number one, just because you have to make all the prototypes physically. It's expensive, it's time consuming, tolerances can be off, and so that can throw you off. And then the other thing is wind tunnel time is extremely expensive. You're probably looking at $600 to $1,000, $1,100 per hour, depending on the tunnel. And so it becomes very time intensive. Not only if you want to make changes, you have to go back, and if you wanted to test hundreds of shapes, it's pretty near impossible. The benefits of software, which is what we use something called computational fluid dynamics software. And in 2015, we built a computer that we mounted to the front of a bike, and it collected over 100,000 data points of wind measurements, both the angle and the relative velocity, that we learned what a cyclist experiences, so that we could actually design a wheel around those parameters as opposed to just guessing at random shapes and putting wind tunnel. We rode it over a number of different Ironman courses, riding through trees, groups, forest areas, along the ocean, beaches, to get sort of an algorithm that we use. That algorithm goes into software, and then in that software, we basically give the software a bunch of parameters. So we say, our maximum rim width, we're going to allow to be, let's say, 28 millimeters, but it can be smaller. We're going to say that our maximum depth can be anywhere between, let's say, 40 millimeters and 50 millimeters. For a 60 mil wheel, we may say anywhere between 55 and 65, or for a deeper wheel, we may say anywhere between 70 and 90. And then we give it some other characteristics that we want to make sure that we're designing around. And so what the software does, with the algorithm that we developed, is it goes in and says, we give it a starting shape, which is generally our last generation of wheels. It benchmarks it, and then it says, well, I'm going to change that rim shape. So it moves and modifies the rim shape, and then it retests. And then it says, was this faster or was it slower? And based on that answer, it record something and says, well, this is an improvement, and we keep moving in that direction, or we go back. And what that allows us to do over a very short amount of time with a supercomputer is we can test hundreds of rim shapes to basically optimize around a specific tire size that we scan, around whatever rim depth we want. And so we give it the freedom to move, and then it eventually gets to a point where it keeps testing, and it can't find anything that's faster. So that's what we did with the 77. We gave it a huge range, and it actually settled not at the deepest. And that's why we know now that deeper isn't always necessarily the fastest. So that's how we do that.
All right. Awesome. Do you want to chat about the new wheels? And
yeah.
All right. So do they? I know. I'm sorry.
Go ahead.
One of the things is one of the things we've heard from you riding them and Chris riding them is that they feel awesome.
They do. I'm not just saying that because I made them. They do. So one of the things we've, like I say, we've increased the internal rim length. The real reason for that was we wanted to understand at the end of 2015, early 2016, when we were finishing the design of the previous generation, we had optimized only for aerodynamics. And we were joking when we left the wind tunnel saying, well, how do we design a wheel that's faster? And at that time, we had actually done a study in the wind tunnel based on tires and to see what they would do aerodynamically. A good friend of ours named Tom Anhalt at the time was starting to do some research on rolling resistance. Rolling resistance is basically how much energy it takes you to roll a wheel forward and the deformation of the tire. It's a lot more complicated than that. And we have some really cool blog articles if you want to read about it. But what we were learning at that time, and he was learning, was that certain tires are a lot easier to roll than others. So his idea was, hey, why don't we mix your aero stuff and my rolling resistance stuff? We'll look at the wattages between the two of them, and we'll figure out what's faster, what's the fastest tire. And so in my mind, I didn't think rolling resistance was going to be that big a deal. Well, Tom data came back, and I was kicking myself because what we realized was that we were only really looking at half of the equation. Rolling resistance had such a huge impact. It was as important as aerodynamics. For example, a poor performing rolling resistance tire, something like a Continental Gator Skin, which is actually pretty aerodynamic, on an Ironman you can lose 8 minutes if you were to use something like a Continental GP at the time 4000. So we knew at that time that rolling resistance was huge. That answered our question, what's the next iteration for us going to be? We wanted to design a wheel that was not only aerodynamic, but could we do something to a rim profile that would lower the rolling resistance? And we knew that wider tires were performing better with rolling resistance. And so if that was changing, could we increase the rim width, make it wider again still, and the tire, comparatively, because if you widen the inside, that means your tire casing width gets a little bit wider. Would that have an effect? And that was about an 18-month to 2-year process to be able to collect that data on the road. It's a very long story. We work with some really great people. UNLV, the team down there were phenomenal. Work with guys out of Calgary, a group called Aerolab, with a very special sensor that's state-of-the-art, cutting edge. And we were able to prove that rolling resistance, wider rims are faster. And we're super excited about that. So not only does a wider internal rim with lower rolling resistance, it also makes for a more comfortable ride. You're widening, you're able to use bigger tires. It feels much more like riding a mountain bike than like something very hard. So I'm excited about that.
Mm-hmm. So we kind of talked about how much do you need to spend on new wheels if you're thinking of upgrading these days. What's a good price range to look at, and for quality?
Good question. If you are looking for a new set of wheels, this is not a seminar to sell wheels. It's just to talk about them. But a lot of people ask about pricing as well, so we'll talk about it. But if you're getting wheels from a good manufacturer, you're going to get a good product. The question is how does that manufacturer sell that product? There are two ways generally. One is through standard retail, which means that there's a manufacturer, They then sell the wheels to a distributor. The distributor then sells them to a bike shop, and then the bike shop sells them to you. And each time that product changes hands, it's pretty much doubles the price. For us, we sell directly to the consumer. So that means that we make them, and then we sell them to you. So we cut out the distributor and the bike shop. So that means that the price is considerably lower because it's not marked up 2 additional times. If you're looking at a lower cost wheel from somebody who you can find in a bike store, bike shop, typically you're going to see things that are going to be different. You may have a hookless rim, cheaper to manufacture. You may have spokes that are not something like a SAPM CX-Ray. That's going to bring the cost down. We have other components in there that aren't quite right. So one thing you want to really consider if you're going to buy a wheel and you're going to really compare them is you want to look at the full spec. So if they're both using the same spokes, check. Both using a hub that's comparable, check. Both using a rim that's a good quality rim, check. Those are some things that you want to consider. Any wheel brand right now that's making something along those lines, it's going to be a good price. Our wheels are in the $1,400 to $1,500 range. You may be able to go down to $1,200, depending on the brand. I don't know of one off the top of my head. My understandings are still probably one of the price leaders. And you can go all the way up to about $4,500 for a set of wheels. So there's nothing about our wheels, in my opinion, that I would say you would limit yourself with, or if you were to buy a competitor. I'm not even saying you would necessarily limit yourself there. It's really the way that we go to market, and it's the main difference. So if you're looking for something, a good set of wheels, make sure it's a reputable manufacturer. You get the right components, and good customer service.
There you go.
Awesome.
Did we cover this one?
I think so.
All right.
Well, thank you very much for listening, tuning in. We hope that you enjoyed this. Something that we figured we could do. I had some fun in the garage, cutting things up and making demos. Thank you for my lovely interviewer. And I think our dog is asleep now because he's bored out of his tree. But hope you guys had a good one. If you have questions, you can email me directly, Jon at flowcycling.com. Get us on Facebook, Instagram, anywhere like that. And hope everybody's staying safe. Make sure you're riding safe, staying away from people. And let's get this thing over so we can get back to racing, which we all love.
Awesome.
See you guys.
Bye.